right? Well, looks like majority of you are back, re-energized with coffee and fueled with filled pastries that are really good in Europe. In the US, they're like 5 times sugar and 6 times worse. So really enjoy them. What? Okay. I'm speaking the truth. So we just heard a nice introduction to the kernels. Let's talk about the toolkit. So this tutorial is going to cover a number of topics. It's going to talk about toolkit architecture, about toolkit contents, various characteristics, how we assign versions, capabilities of the toolkit, directory structure, application programs that we include. Those will be mentioned briefly, and documentation. So Spice Toolkit is officially available in Fortran, C, IDL, and MATLAB. And these toolkits are available at this URL from the name server. In addition to them, our group developed a beta Java native interface version of Spice, GNI Spice, and it's available in a different location on the server. Well, this beta Java native interface version has been out for a very long time. So it's been tried in many heavy-duty applications, and we believe it's working, but we still cannot cast it as fully official toolkit because we haven't done as good a job on documentation as we did in other versions. So all toolkits are packaged and delivered as standalone products, but IDL, MATLAB, and GNI Spice toolkits also include C Spice because they're essentially a wrapper around C library. Well, other people created Python toolkits, which majority of you will be using. One of them, particular SpicePy, but that's not the only Python implementation available. There is another implementation that's done at SETI Institute by the people who are part of the PBS Strings Moons node. So if you look at this diagram of toolkit architecture, you will see that everything starts from the left side with the Fortran toolkit. In this Fortran 77 toolkit, we develop all the core capabilities, and they become part of the Spice library, Spice Lib. The Spice applications and programs that link to this Spice library to provide some auxiliary functions, but more importantly, you as the users link to your applications to get access to kernels and to do derived quantity computations. The C toolkit is generated from Fortran toolkit by translating Fortran code to C using F2C, which generates really ugly code, which isn't native to C programmers. To make the situation easier for the C programmers, we write special C wrappers, which have more native interface for C programmers, and they call underneath the translated code, hiding it from the users. Those who use C toolkit from user application programs call this C Spice library, and our applications still call F2C code in it. In a similar fashion, the IDL toolkit IC has an additional set of wrappers written in C that provide bindings from IDL to C Spice wrappers, and scripts that user write in IDL will call these wrappers IDL wrappers, while our utilities are still calling after C code. So that's why C Spice is included in IDL package. And in a similar fashion for MATLAB, we wrote MATLAB wrappers, both in pure MATLAB and with a bridge in C. The user scripts will call these MATLAB wrappers to do geometry computations. So a similar situation is for the GNI Spice toolkit, where GNI Java wrappers call the C toolkit, and for spiftp, which is a Python wrapper around the C toolkit. So the software that we deliver, the software packages include software itself, documentation, and some example data. And the main part of the software, of course, is the subroutine library that your scripts and applications call. It has different names in different languages: Spice Lib and Fortran, C Spice and C, IC and interesting. IC was a bridge written in C, and mice was a bridge written in C and MATLAB. We'll provide some executable programs, which will break down into 2 categories: application and utility programs, depending on how important the things that they do. And we'll also include some example programs. They're called cookbook programs, and normally have the word cook in their name. Also included are installation and build scripts, which, if needed, you could rerun yourself to review the toolkit in place, but normally you would not need to use these. We provide documentation in plain text and HTML format and a little bit of example data. This data is not for you to use for any real computations. This is just to support these cookbook programs. And they were important in the past, more important in the past, when we had fewer examples in the documentation for various APIs. And they're less important now because majority of API documentation includes working examples, which are a better starting point than these cookbook programs. Well, let's see. Toolkit has many important characteristics. Computations are identical in all languages. So if you try to compute position of the Earth as seen from Mars in J2000 frame using Fortran toolkit, C toolkit, IDL toolkit, MATLAB toolkit, or spiftp, you will get the same numbers for the same time and the same kernels. Because the core of computation, all of computations are done by this core Fortran toolkit, which is carried on as converted C code into all other toolkits. So for a given computer and operating system, all toolkits use identical kernels. So there is nothing special about loading a set of kernels into MATLAB mice-based application or spiftp-based Spice application. Well, the code is well tested before we release it. As you could see on our native server, we have many different packages for different environments for each of these languages. Each of those packages went through extensive regression tests. And we only release toolkits when all of the errors, all of the warnings, everything is gone from the code. So new toolkits are always backwards compatible. We already mentioned them. So if an application worked linked against an older toolkit, if you relink it against new toolkit, we guarantee that it will work. Past functionality is never changed or removed, with two exceptions. We can make some enhancements, and we reserve the right to fix bugs. So the real bugs in the code, yeah, we'll fix it, and the behavior will change, but that's for your benefit. We have extensive user-oriented documentation, and you will have a chance to explore and use it during this class and in your future Spice work. So I already mentioned toolkit version. It's just a number, and 66 is the current version. We don't release toolkits on a particular schedule. The new releases are primarily driven by new significant capabilities that we add to the toolkit. The latest significant addition was digital shaped kernel subsystem. Before that, it was generic. It was dynamic frame subsystem. Before that, it was runtime translation for binary kernels and so on. So we have some big capabilities that we were working on, and when we believe that these capabilities are mature enough, we make new toolkit of the version of the toolkit, increment the number, and make it available on the native server. Well, on rare occasions, we release toolkits to bug fixes. We haven't had that for the last probably 10, 15 years. And sometimes, even less frequently, we release a toolkit that satisfies an urgent request from a flight project. So we haven't had that in a long time as well, because multi-mission capabilities available in the current toolkit are usually sufficient for all the projects that decide to take on using Spice toolkit. So Spice toolkit libraries contain a broad set of capabilities related to computations needed for determining observation geometry. And there will be a few slides that explain them in detail. Not all functionality is present in all 4 language versions. So Fortran and C toolkits are pretty much the same, although even here, C Spice has fewer public APIs than Fortran does. We did not create wrappers for some very low-level routines. And if you really wanted to use them, you would have to do it from the Fortran toolkit or call F2C version. And C Spice requires explains how to do it. For IDL and MATLAB toolkits, they pretty much duplicate the most functionality available in C toolkit, but also not all of that functionality. So sometimes you would have a wrapper in C Spice for which you will not have an equivalent in IC and mice. I think that spiftp situation is actually a little better. I believe spiftp wrapped pretty much all of the C Spice wrappers that we have. So in terms of functionality, it's much closer to C Spice. Well, we're aware of this, and we add additional interfaces as time permits. So let's talk about toolkit library capabilities, the APIs that you would call and what you can do with them. Of course, first and foremost, you need to access kernel data. And for that, you will need to load kernels. We'll provide a routine for that, furnish. We'll provide routines for getting state and position vectors, getting orientations of planets, natural satellites, body shape parameters and physical constants, orientation of spacecraft and spacecraft instruments, instrument parameters such as field of view, digital shape data, or get data from binary e-kernel files. So all these, of course, will need to read some kernels, but we'll also provide routines for creating kernels. We provide routines that are type-specific to write SPK files, CK files, PCK files, and so on. We have a few additional ephemeris functions, a function for computing classic oscillating elements, for propagating states using two-body Keplerian propagation, for evaluating NORAD to line elements, and for computing lifetime and aberration corrections. The routines for computing frame transformation, both 3x3 matrices and 6x6 matrices for states. Many routines for time conversions between standard system, TDB, TDT, and also between clock, onboard clock, and other time systems, and some routines for parsing and formatting time tags. We already mentioned geometry finder calculations, determining set of times or time windows when a particular geometric condition is met. It could be when the specified situation is true, like occultations, or when a certain geometric parameter is within a given range, or at the maximum or a minimum. We have quite a few math routines in the library. Those are needed primarily for supporting computations that are done within the toolkit, but they're also available to new users. They include some vector and matrix operations, rotations, Euler angles, and quaternion conversions, coordinate system conversions between latitudinal, spherical, rectangular, right ascension, declination, geodetic, and planetographic coordinates. We have some routines that deal with shapes, such as ellipsoids, ellipses, and planes. And unfortunately, in this slide, we've bundled high-level functions, which is the main thing that you would choose SPICE to do, such as computing illumination angles, sub-observable points, sub-solar points, and surface intercept points in this category, when they really belong in their own big category, because these routines make use of SPICE kernel data and these math, more low-level math routines and many other things, and time conversion routines to give you the results that you're looking for. So there are a few routines that return constants, such as Julian epochs, seconds per day, and the value of pi, and so on. They're auxiliary, but they're used extensively in the SPICE library code internally. There are some routines for parsing strings. Those are needed to provide flexibility for many other SPICE subsystems and for SPICE utility programs, but they're also available to you, such as numeric conversion, replacing markers, generating suffix and prefix. Not all these routines are available mostly in Fortran and C. Not many of them were wrapped for MATLAB and IDL. So there are also auxiliary routines that deals with arrays for sorting, finding order vector of arrays, searching through arrays in linear and binary fashion, routines for name ID conversions, for bodies, frames, and surfaces, which is mentioned here. For supporting I/O in the Fortran, logical unit management, opening, reading, writing text files, for exception handling, for generating error messages that you see when you do something wrong with SPICE, and for giving you a handle on changing that behavior. There will be a tutorial on this, and there's a lesson on changing error handling in the other lessons package. And also some routines for advanced data types, which are very useful in Fortran, which doesn't have such types built into the language. Of those, the important one is windows. Sometimes we call them schedules, which is a data structure that holds series of time intervals that can be input to geometry finder routine and output from geometry finder routines. So now let's talk a bit about toolkit directory structure. The toolkit directory structure for the 4 kinds of toolkits is almost identical with one exception. In CSpice, IC, and MICE toolkit, there is a directory for include files. Well, the names for applications, application source directory in the toolkit are slightly different as well, and I'll show that when I'll do a demo in about 5-10 minutes. So MICE and IC directory, of course, include additional subdirectories for the library source code itself, IC and MICE source code, and IC and MICE toolbook programs. Now, the top-level directory, depending on the language, is called differently. For the Fortran toolkit, it's just the toolkit. For CSpice, IC, and MICE. It's sort of self-explanatory. Under the top directory, you will see a few subdirectories, which I will show on this on the next slide. So the first one you will see is data. This one does not contain real data. It's just these cookbook kernels that you might need if you wanted to run cookbook programs, so you shouldn't pay much attention to it. Doc directory, on the other hand, is very important because each toolkit includes a full set of documentation applicable to that toolkit. And documents come in two formats. They're text documents with these strange extensions, but they're just plain text that you can load in a text editor or look at in your terminal window. And there is a single subdirectory called HTML, which underneath contains all of the HTML documentation. In this HTML subdirectory, there is a file called index.html, and this is really a single entry point into all of SPICE documentation tree provided with the toolkit. So once you loaded that index, you will see links to toolkit description document, to introduction to SPICE, to reference index for all of the APIs for the toolkit version, to user's guide, and so on. There is a etc. subdirectory. It's normally empty in generic toolkits, but in certain extended toolkits which we used to deliver to flight projects, it did contain some additional things. exe directory contains executables of SPICE application and utility programs. I'm not going to list them all. You will have a chance to hear about them in the subsequent tutorials. And it also has executables for the cookbook programs, which I mentioned earlier. It's very, if you're planning to use SPICE, well, you are, since you're in this class, it's very helpful to include this directory, the full path to this directory, into your system path. So when you open your terminal window or DOS command window in which you would like to run the utility to get the summary of SPICE kernel, you don't need to type the full path to the subdirectory. You will just type brief or ckbrief or whatever name of other utility, and it will do the job, letting the operating system to find it in that subdirectory. So include directory, as I said, includes, it applies only CSpice, IC, and mice. It includes API header files, which you will include in your C applications, and which are included in the IC and mice implementation C modules. Under the lib directory, we provide precompiled libraries that you will link your applications to. For Fortran toolkits, the main library is called SpiceLib, and they will be either spicelib.a or spicelib.lib, depending on the environment. This is the main library in which we'll provide public modules. There will be another library called Support, with extension appropriate for its environment. These are private modules. We call routines from this library from various application and utility programs, and users should not call anything from that library. Now, for C toolkits, the main library will be called cspice.a or .lib. For IC toolkit, the library that you will need to make available to IDL using add-path command is ic.so or ic.dll. And for mice toolkits, it's going to be called mice next, and then the final part of this extension will be platform-specific. Because IC and mice toolkits also include CSpice, you will see that they also contain the CSpice library and C support library. Now, and finally, under the source subdirectory, we provide all source code for all libraries and all utilities, all programs that are part of the toolkit. Under this source directory, you will see subdirectories, which will correspond to the name of the library or the name of the utilities. And under these subdirectories, you will have different source code file types, .f and .4 for Fortran, include for include files, .cs, and so on and so forth, depending on the language. So that source code is available for you to look at, and in a way we sometimes think of this source code as additional documentation for our toolkit. So if you really wanted to see how a certain algorithm is implemented in SPICE, well, feel free to go and look at the source code. Word of warning though, so if you're dealing with a CSpice-based toolkit, that algorithm is going to be embedded in a module that was translated by F to C. Of course, when you're translating Fortran to C, you can kind of discern the logic and structure, but it's going to be all jumble mumble with many additional things that get in the way. So I strongly recommend that if you really wanted to see what SPICE does, no matter which toolkit you're using, try to download Fortran toolkit, find the routine that is actually doing the job, and look at the code of that routine. Fortran is one of the simplest languages, and we're using Fortran 77 a version of it which is a smaller subset without any extension. So anybody who is familiar with modern languages should be able to read Fortran, and more importantly, should be able to see the comments that we have interspersed with the Fortran code that explains how things are done. All right, SPICE Toolkit application programs. These are programs that are doing more difficult things, let's say, such as programs for creating certain kernel types, make SPK for creating SPK files, MSOPCK for creating C kernels, or make DSK for creating DSK files. There are also programs for comparing and analyzing certain kernel types, such as SPK-diff or frame-diff, for doing various kinds of time conversion. It's called Cronus, and a few additional ones. And we will have a tutorial on the third day of the class, which will describe each of these programs individually, briefly. And you will have a chance to try some of them in a lesson that will be provided at the end of the class. Some additional application programs are available from our website. There are quite a few of them there. We have maybe, I don't know, 8 or 10 programs included in the toolkit, and maybe the same number or even more available only from the name server. And the main reason for it is that we felt that these utilities, additional utilities available from the Nave website, are not as generally interesting, and we didn't want to make toolkits very big, bloated size. But for certain situations, such as the need to make a subset of a C kernel file or make certain other operations with C kernel files, we provide these utilities on the website. So there are additional SPICE utility programs included, and those are for sort of lower level operations, such as adding comments to binary kernels, or reading comments from binary kernels, or summarizing coverage of binary kernels. So they're in the same exe directory, and they're also going to be covered in the tutorial that will be presented later. Well, let's talk about documentation. As I mentioned, all toolkits include all documentation that are relevant for that toolkit in plain text and HTML format. And for HTML format, simply load the index, and I will show where it is. And you will get access to API reference pages, to big reference documents for subsystem users guides and such. Now, individual kinds of documents included in the toolkit, such as module headers, required reading documents, and users guides, are all pointed from that index. Module headers are the most important kinds of document because they provide specification for individual APIs that you're going to be calling. And in this specification, they describe I/O of that API, exceptions that that API can generate, particulars defining its behavior, its version history, and more importantly, they contain an example that will help you get going with that API very quickly. And in more modern, high-level APIs, sometimes we provide multiple examples, and these examples are cut-and-paste kind of examples. So it's really a program that you can execute with kernels that it refers to and get the same results that are provided in the same section. So required reading documents are extensive technical references for principal subsystems. For example, for the SPK subsystem, which deals with trajectory data, it describes all SPK types, how these SPK data items are stored in the files, and so on and so forth. Not all required readings were adapted for all languages. So all of them are available for Fortran. Majority of them were adapted for C. But as you go to IDL and MATLAB, we sometimes didn't do this adaptation and simply provided a CSpice version of that required reading document, which may be sufficient because, as you could see, the high-level interfaces between languages are parallel, both in terms of arguments and have the same names. And users guides tell you how to use utility and application programs. Again, most of them have examples and usage information and such. There are some other documents included in the toolkit. One of them is permuted index. It maps phrases describing functionality to corresponding module names. And for Fortran, this also shows entry points which correspond to a particular toolkit API. There's the toolkit description document, which explains which programs and libraries are included and gives paths to their directories. There is a document, Introduction to SPICE, which explains what SPICE is. You had heard most of the information provided in the tutorials already. There's an important document called What's New in SPICE, it describes new features and bug fixes in each toolkit release for the last 20 years. So instead of generating a new release notes document, we decided to make one big file where we add description of a new version at the top, which serves as a very good record of what we have been doing with the toolkit. And it's very important for users of Spice in the sense that when we release a new toolkit, you can go to the top, the newest section in that file that explains what was added in the new toolkit and decide if that is important to you. And based on that, upgrade or not upgrade to the toolkit. Even though we're backwards compatible, upgrading to a new toolkit requires relinking your programs, installing the toolkit, which is an effort, and sometimes for flight projects which have tightly configuration controlled environments, it's even more effort. And of course, we have a simple document which has a toolkit description, pretty much 2 lines. It just says it's version N66. But it's important for us to know exactly what toolkit you're dealing with. Okay? Any questions? Yes?
For people who are using SpicyPy, would you recommend that they follow links to CSpice headers for detailed information, or is there some other recommendation?
Well, for SpicyPy, there is a very brief description of each SpicyPy wrapper provided in a single big web page, which most of you SpicyPy users are already familiar with. And in each of these little blocks, which covers only input and output arguments, there is a link to the CSpice module, which that SpicyPy routine calls, SpicyPy's interface calls. And in fact, I think at the top of that big file, and your annex says, please go and look for details on this CSpice documentation. And in fact, in the lesson instructions, we asked you to download CSpice Toolkit and place this lesson package in the CSpice Toolkits.html subdirectory in order for links to the reference documents for subsystems, such as required reading documents, and for users' guides to be resolved into the CSpice Toolkit documentation, which is complete, unlike the SpicyPy documentation, which is just a few pointers. Okay. All right.